What's that?
Packet of ketchup. A water bottle with a ketchup packet.
What's it doing now?
It's floating now.
It's floating.
Now it's just.
Oh, there it goes. There it goes.
Oh, wait.
How did you do that?
It's going up again
Magic?
No.
and going down. Can we open it?
This is really tough. I have absolutely no idea. I have no idea.
Okay, so who wants to do some science?
I do.
Sure.
Is that
Oh.
real beer?
Okay, we're gonna do a little bit of hydraulic science. Cool thing about hydraulics is you can do amazing things with it. Start by getting the safety gear on. You all brought your safety gear?
Yeah.
Okay, well, at least I have my safety gear. So, can you compress water?
No.
No, you can't. Can you apply a force through water?
Yes.
Absolutely. And applying a force through water is called hydraulics. And with hydraulics, you can do things like this. Got a mallet here, hydraulic fluid, and I want to see if I can apply a force through that hydraulic fluid.
Whoa.
We take that little area there, and the same unit force that's applied from that little space there is applied equally throughout the entire chamber. So you multiply that smaller force to a much larger force distributed across the entire chamber, and the weak spots are going to give out. And that's really what hydraulic systems do. They can transmit a force from one end to another, and they can multiply the force as well. So what do we have there? We have a bottle of water with a medicine dropper in it, and inside the medicine dropper is?
A bubble.
A bubble, okay. If you squeeze it very slowly, what happens to the bubble? Squeeze it really slowly, and what happens?
It moves up.
It compresses the air.
We're compressing the air, the bubble's getting smaller. Ooh.
Is it moving higher into the medicine dropper, or is it compressing the air inside?
Well, so what do you think?
I think it's compressing the air.
Well, it's actually a little of both. Because when you apply a force on the liquid, that force is distributed equally in all directions, and that means you're forcing water up into the medicine dropper, and you're compressing. The force you apply on the water is applied on the bubble as well. And if you make the bubble smaller, if you make the bubble small enough, what's going to happen? Give it a squeeze. Hold it up straight. Hold it up straight. Give it a squeeze. Ooh, what happened?
It fell to the bottom,
Let go.
and it goes back to the top.
What's the connection between that bubble and the exploding bottle?
Anyone else? Pressure.
It's pressure. It is. It's the transmission of the force. In this case, we're transmitting the force gently, and you're seeing a gentle transmission through the liquid into the bubble. When we took our bottle, we transmitted a force rapidly and aggressively and strongly. We took a force applied across that little bit of stopper, and we made it like this big because we transmitted it to the whole bottle. Which brings us full circle back to this baby. I present to you the most amazing Science and the City hydraulic-powered science. That's the name of our segment.
Very nice.
We're filming Science and the City.
Excellent.
Yes. Watch that, the package there. What's it doing right now?
Floating.
Floating. Okay. Uh-oh. I'm doing exactly what we did with the medicine dropper, except now we can't see the bubble. The little bubble inside the ketchup package is being compressed. I can do the same thing just by squeezing that. You want to try it? Or you can do it as I was doing it to start. So, at the end of the day, I got to ask you a couple of questions. First question, can you compress water?
No.
Can you compress a gas?
Yes.
Can you transmit a force through water?
Yes.
And how is that force transmitted?
Equally over the entire area.
Excellent. There you go. You guys rock. You must be York engineers.
Whoa. Nice. Sweet.